Hi friend, this is Shomik Bishwash and today we are attending the class of superposition theorem, that is the content under application of network theorem in DC and AC analysis or DC and AC networks. So here our today's objective is superposition theorem on AC circuit. Now if you are having this particular name superposition theorem, so I have discussed it actually what is superposition, but still for this class we have a little bit recapitulation. Here you will be having one circuit which having three different part. One is a voltage source, the mesh of the resistance, and another voltage source. Here it is 50 volt, it is 100 volt, and the T junction of 5, 15 and 10 ohm resistance are there. So using superposition theorem you have to find out that current to that particular 10 ohm resistance branch. So how to do this? First of all, you are making it short, and after making it short, so the total current for this particular branch is governed by that 50 volt source. So obviously we are calculating this is as 50 by 11. Now again, when we are calculating this for this particular one, just make it short. So it is 5 and 10, they are parallel to each other, so it is 5 cross 10 by 5 plus 10, so 50 by 15. So it can be calculated out as 3 by 10, so it is 45 and 10, so 55 by 10, like this you can calculate it out. So finally you have to find it out, and that is coming as 18.33. so by the solving of I1 and I2 we will be finally getting that current 4.54 ampere, which is same for using superposition, nodal analysis. That mesh analysis theme is not on, I worked it out in my previous classes, you can follow my earlier video lecture. So the today's topic is superposition theorem on that AC circuit. One problem here, question number 3, that is one voltage source V1 that is given 10 angle of 60 degree, one inductance 6 Henry as J6, that is resistance 6 ohm, that is 6 ohm, one current source I1 that is 2 is amplitude and that angle is 0 degree, one condenser or capacitor is there having that value minus J8 ohm omega. So find out the current. Now here all are in omega scale. So how to do this? First keep this one on, that is plugged off. So finally the current you can easily calculate it out as V1 by that entire thing. So how to do this? First of all, what is the voltage here is V1, so you just write it as V1. Now if this thing is not there, just put your finger in this way. So it is J6, 6 and J8 right here. So these three, so J6, 6 and minus J8, so that is equals to 10 angle 60 it is given by the calculation of this is equals to J2, 6 minus J2. So just amplitude modulus conversion like this, I already told you in the previous Norton's and Thevenin's AC examples. So just subtracted it out and you will be getting I2. In the same way, when this is shorted and this is active, so the current is getting two paths, one and this and this. So what is the current flow of that I2? Here I2 is that particular current they are demanding, so that is J6 by J6 plus 6 plus minus of J8, this one, so that is 1.9 into this. How to get that? What is I2 basically? When this is active, so this current is flowing and this current is flowing. What is V1 when this current is coming in this way? So this is I1 and this is I2, so all are this passing to that 6 J6, so they are demanding current to that 6 ohm only. So you have to find it out how to get that, what is current for this branch, if you're taking the resistor divided bias, so it should be J6 by this J6 plus 6 plus 8. As I have told you in earlier class, that is R2 by R1 plus R2 is the dedicated current for I1 if you're taking symmetrically, say. So I2 dash equals to this. Here I is given, I have calculated, that is 2, this is total I, 2 angle of 0 degree, so I'm just putting it this particular one, and finally getting 1.9 angle of 108.43 ampere by this. So when you are multiplying this, okay, this particular one, we can do it in this way, that when they are multiplying that angle, they are actually adding up. When the angles are in the divided phase, they are subtracted up. So here you can easily make it the amplitude modulus function, and finally you can calculate the total angle and that value of this triode. This is multiplied 1 divided easily. So that is 1.9 into 108.43. That is the answer. That is for I2. Here, now when you are doing this final answer, so it should be I2 plus I2 dashed. So you are adding these two values actually. This is the final answer. So using superposition theorem, the AC current can also be calculated out, as you have seen this particular problem. Again, in the next lecture, I will give you more examples on the different theorems. So for today, we'll be having one more problem, that is question number 4. Here is a messy part is there in this circuit, that is the combination of different resistance and capacitance inductance like this. So they are showing as that impedance style. So this value is 2 plus J3, this value, that is 10 ohm resistive. This is 5 ohm, that is 4 minus J6, and that is 10 ohm. So messy structure is there. Two current source, one is 50 angle 0, another is 100 angle 30. Now you can solve this in many more ways. So here for the superposition, first we are removing this. So current is flowing to this particular circuit. So what is the value here? It is 10, 5. Now when this particular current source is removed, so we are getting what is I1. So here generally that is not the current source, that is a voltage source, because in that AC the symbol is this, if it is, so it obviously voltage source. So using superposition, the voltage source must be shorted like this. So the current coming from this, it is having 3 way, that is this is finally it is shorted and coming out in this way. Okay, so what is the net resistance for this path? That is 10 and 10 plus 5. Okay, so this is 10 and 5, these are in the this is in this case. So okay, that is 2 plus J3, that is 4 minus J6. So if it is shorted in this way, so the current will not follow that path. Why? Because if it is taking this path right here, the same thing will be back to this. Okay, in my earlier classes I have shown such examples. So this particular node should not have any current, this node too. So actually the total current is the combination of 10 and this is. So finally this is there, 10 and 5 are parallel to each other and 10 is series. So finally this is I1, 50 angle of 0, 10, 15, 5 parallel with that angle of 10. So it is finally getting as 3.75 of 0 degree angle. Okay, now when this is on and this is shorted, still these are of no use. Okay, so finally it is 100 angle 30 10 parallel 5 10, so it is 7.5 angle 30 degree. So the current through that 5 ohm resistance here is basically following that resistor divided bias, so it is 10 by 10 plus 5. Okay, so finally it is 5 angle of 30 degree. So the total current is here, that is 5 angle of 30 degree 5 ohm, and initially it is 2.5. so this is 2.5, so you can easily factor it out as 2.5 plus 4.33 plus this 5. So finally the answer is 6.83 plus j into 2.5. that is the final answer. So that is in short of all that problem. Here 2.5 is clearly referred, that 3.75 is a current, I have find it out. So what is through that load? So here the combination is just reverse, so it should be 10 by 10 plus 5. Here it is 2.5, like the same way. In the second case it is same, so it is 5 and this is 2.5. if you are adding them up, so finally the answer is like this. So why I have to again make it in the class of complex series? Because one is 30 degree, another is 0. If both are 0 degree, so I can easily add them up. But here you have to write in that case of a plus j b or a plus ib form. Okay, so it should like this, 2.5 plus 4.33 plus j into 2.5. so finally the answer is 7.273, but means this is the final value you will be getting. So if you are taking again amplitude modulus conversion, so it will be the final result. So that is in short the full lecture of that application of the superposition theorem in AC circuit. So now on, my request to all my pupils, my students and the follower of the channel, that please do as much as you can this type of numerical problems. So these lectures you should take as a reference of this. So many more problems are there in my more forthcoming videos. I will publish many more type of numerical problems using that superposition and the Thevenin's and Norton's theorem. And one thing you should keep in mind always, that the theorems are the different way to solve problems, but the problems, if it is truly solved for a particular query, obviously if it is network theorem, so what is done by KVL, KCL, mesh and node analysis, the same thing can be done by the Thevenin's theorem, by the Norton's theorem, this way. But in the case of AC circuit, you are not using that KVL and KCL, but the Thevenin's and the Norton's and superposition both have the same answer. So for the betterment of the practice, if you want to go much more deeper of this particular subject, so you should practice a lot of, and obviously one particular problem should be done in different way. One superposition problem should be done in Norton way, one Norton problem should be done in Thevenin's way. Like this, then you will be getting a quite free of handle of it. So wish you all the best. Follow my lectures in the next class. The topic will be the Millman theorem and the maximum power transfer theorem accordingly. So wish you all the best. See you very early next. Bye bye.